Fine, let's start. Number 1. The Trachilos footprints, Crete. In 2002, a Polish paleontologist named Gerard Gierlinski was on holiday on the Greek island of Crete. He was walking along a coastal outcrop near a small village called Trachilos, 2.5 kilometers west of Kissamos. The tide had drawn back and exposed a slab of pale Miocene sandstone. He looked down. There, pressed into the rock, were prints with 5 toes and an arched midfoot. They looked human. He did not publish what he had seen for 15 years. The find was too disruptive. When he and Per Ahlberg of Uppsala University finally released the paper in the Proceedings of the Geologists Association in 2017, the global paleoanthropology community treated it as a possible bomb. Roughly 50 prints had been mapped. They sat in laminated sediments alongside ripple marks and desiccation cracks. The depositional environment was a coastal salt marsh on the edge of the Proto-Aegean Sea. The first date was the headline. Foraminifera microfossils in the host rock placed the Trachilos surface at about 5.7 million years old. 4 years later, a team led by Uwe Kircher refined the chronology using magnetostratigraphy. The new figure was older still, roughly 6.05 million years. That number put the prints contemporary with Sahelanthropus chadensis, the earliest commonly accepted hominin from Chad. The print anatomy is what makes the find genuinely uncomfortable for the standard model. The big toe, called the hallux, sits in line with the other digits, not abducted off to the side as it is in living chimpanzees and gorillas. There is a clear ball pad. There is an arched longitudinal midfoot. Sizes range from 9 to 22 centimeters in length, suggesting both juveniles and adults of a small bipedal species. The textbook story holds that bipedalism evolved in East Africa, with hominins like Sahelanthropus and Ardipithecus, and that members of our lineage only reached Europe much later, as Homo erectus, around 1.8 million years ago. The Trachilos prints, if they are what their describers say they are, put a bipedal hominin in southeastern Europe 4 million years before that. There are skeptics. Robin Crompton and William Sanders have argued the prints could be tetrapod traces, possibly bears or apes with convergent foot morphology. No candidate species has been named to date. 3 readings now circulate. The mainstream insists the East African origin holds, and Trachilos must eventually be reinterpreted. The archaeological alternative points to Gracopithecus freibergi, a late Miocene hominoid from Pyrgos Vasilissis in Greece, dated to 7.2 million years, as a plausible trackmaker. The fringe reading invokes a so-called Aegean cradle, in which bipedal hominins originated on a chain of Mediterranean islands and only later drifted south. The Trachilos specimens are curated at the Natural History Museum of Crete in Heraklion, and what they mean is still being argued. What happens next in this story is the moment a volcano starts to erupt, and ancestors run. Number 2. The Devil's Footprints of Roccamonfina, Italy. In rural Campania, just north of Naples, the slopes of the Roccamonfina volcano carry a trail that local peasants have known about for centuries. They called it Ciampate del Diavolo, the Devil's Trails. They believed only Satan could have walked across molten lava and survived. The rock the prints sit in is called brown lucidic tuff. It was once a layer of hot ash from a sub-Plinian eruption that blanketed the volcano's flank with a mix of lapilli, ash, and lucite bearing pyroclastics. In 2003, a team led by Paolo Mietto, Marco Avanzini, and Giuseppe Rolandi published the prints in the journal Nature. The tip had come from an amateur archaeologist named Adolfo Pannone. The initial mapping documented 3 trackways totaling 56 footprints. Later seasons added 2 more trails, bringing the count to 5. The dates came in next. Argon analysis of the tuff returned a Middle Pleistocene age of between 345,000 and 385,000 years ago. The Berkeley Geochronology Laboratory in California provided the cross-checks. Those dates placed the walkers firmly in the era of Homo heidelbergensis, the European archaic ancestor of Neanderthals. Heidelbergensis skeletal fossils of the same period have been found at Ceprano and Visogliano elsewhere in Italy. The slope itself was steep. In places, the gradient reached 80 degrees, and the ash was still partly hot when the walkers crossed it. Stride length and depth analysis put the walkers at about 1.5 meters tall. They moved in a zigzag pattern to maintain balance on the unstable surface. One trail includes something rarely preserved at any site of this age, a clear handprint, off to the side, where one of the walkers steadied themselves against the slope using their right palm. That detail matters. The handprint is direct, behavioral evidence of an ancestor making a conscious adjustment, reading the terrain, choosing the safer route. Roccamonfina is one of only 2 Middle Pleistocene sites globally with associated hand and foot traces. The other is Laetoli in Tanzania, much older and African. The foot morphology shows a modern arched longitudinal structure and a non-divergent big toe, consistent with full bipedalism. There is no transitional gait here. By 370,000 years ago, in Italy, these ancestors walked exactly the way we walk. 3 readings persist. The mainstream account is the cleanest. Homo heidelbergensis evacuating an active volcanic landscape, fleeing the eruption that buried half the countryside. The archaeological alternative proposes the walkers were not fleeing, but inspecting, perhaps hunting animals disoriented by ash. The fringe reading, still alive in older Italian folklore archaeology, treats the prints as evidence of a firewalking ritual by an unknown sapient population. The University of Padua now holds the laser scans, with millimetric reconstructions of every step. What lies next is a trail of footprints whose age has been argued over for 150 years. Number 3. The Acahualinca footprints, Nicaragua. In 1874, quarrymen working a layer of limestone on the southern shore of Lake Managua broke through into a deeper deposit of volcanic mud. They found a trail of prints embedded in the hardened material. The discovery happened in the district of Acahualinca, on the edge of the growing Nicaraguan capital. Today, those prints sit roughly 4 meters below modern street level, beneath a roofed pavilion called the Museo Huellas de Acahualinca. The museum, founded in 1953, is the oldest in Nicaragua. The American geologist Earl Flint visited the site in 1884 and published a description for the Peabody Museum at Harvard. He counted somewhere between 5 and 15 individuals, all walking in the same direction. The print lengths ranged from 21 to 27 centimeters. Most estimates put the makers at about 1.45 meters tall. The dating is where the story falls apart. For decades, the prints were assumed to be roughly 200,000 years old, based on faulty stratigraphic assumptions about the volcanic ash above them. Then, in the 1960s, the first radiocarbon assays came back. The age collapsed to about 5,945 years before present. That should have settled the matter. It did not. In the 1980s, Alan Cobb and Nicaraguan geologists revisited the site. Their analysis suggested the prints might be even younger, closer to 2,100 years. In 2018, the geologist Joaquin Mate Hernandez applied thermoluminescence dating to the surrounding sediment. His number came back at about 2,120 years, supporting the younger range. So how old are they? Anywhere from 2,000 to 6,000 years, depending on which assay you trust and which lab ran it. The site sits on Nicaragua's tentative UNESCO World Heritage List, partly because of this dating chaos, not in spite of it. The eruption that produced the ash is now thought to be from Masaya Volcano, a still active shield volcano about 20 kilometers south. The walkers crossed wet ash that hardened into tuff. Their gait shows no running. Strides are calm, evenly spaced, and the depth of impression is consistent. Some prints show deeper heel impressions in alternating prints, suggesting the walkers were carrying loads. Deer, bird, and possibly domesticated dog tracks are interspersed with the human prints. This destabilizes the popular image of the site, which casts the walkers as panicked refugees. They were not running. They were walking calmly, possibly carrying things, possibly accompanied by animals, and possibly heading toward the volcano rather than away from it. Mainstream interpretation: a small indigenous group caught in a volcanic mudflow. Archaeological alternative: a ritual procession toward the lake. Fringe reading: pseudo-archaeological writers have proposed a pre-Younger Dryas lost civilization of Central America. None of those readings answer the central question, which is simply, when? The next site solves the dating problem, but raises a worse one about who the children were. Number 4. The Theopetra cave footprints, Greece. In central Greece, in the region of Thessaly, the rock pillars of Meteora rise like cathedral spires from the plain. 4 kilometers south of Kalambaka, at the foot of a separate limestone outcrop, sits the village of Theopetra. The village gives its name to a cave that has been excavated continuously since 1987 under the direction of Nina Kiparisi Apostolica of the Greek Ministry of Culture's Effort of Paleoanthropology and Speleology. The cave's stratigraphy is one of the most complete in southeastern Europe, spanning roughly 130,000 years from the Middle Paleolithic to the Neolithic. Inside, the floor preserves a remarkable layer of soft, clay-rich sediment that hardened soon after a brief flooding event from a nearby spring. Pressed into that layer are 4 footprints. They are very small. Print lengths range from 10 to 14 centimeters, attributed to children aged roughly 2 to 4 years old. The age of the layer, established by thermoluminescence dating, is approximately 130,000 to 135,000 years ago. Now the trouble begins. Whose children were these? The dates fall in a period that the standard model assigns to Neanderthals in southeastern Europe. By 130,000 years ago, the European continent should have been Neanderthal territory. Anatomically modern Homo sapiens, by that model, were still in Africa. Then, in 2019, Katerina Harvati and colleagues published a paper in Nature on the Apodema 1 skull, recovered from the Mani Peninsula in southern Greece. The skull was dated to approximately 210,000 years old. It was attributed to Homo sapiens. That is 60,000 years older than the Theopetra footprints, and it places sapiens in Greece long before the standard timeline allows. The Theopetra prints sit awkwardly between the Apodema sapiens evidence and known Neanderthal layers in the same cave. Attribution becomes genuinely ambiguous. The children might have been Neanderthal. They might have been sapiens. They might have been a population we do not yet have a name for. Theopetra also holds the oldest known artificial wall in Europe, a stone barrier roughly 23,000 years old at the cave entrance, possibly built to block cold winds during the Last Glacial Maximum. Excavations have produced over 50,000 artifacts, including Mousterian stone tools, Aurignacian blades, ceramic figurines, and Neolithic pottery. The cave is now closed to the public for conservation, with replicas in a museum building at the entrance. 3 readings circulate. The mainstream account holds that the prints belong to an unidentified Middle Paleolithic hominin, possibly a regionally distinct sapiens population. The archaeological alternative suggests the children's presence reflects a brief play behavior or ritual deposition, given the absence of adult tracks in the same layer. The fringe reading uses apodema to argue for a far older European Homo sapiens population that the standard out-of-Africa model cannot explain. Greece's tentative UNESCO World Heritage listing for the meteorocultural landscape now includes the cave. The next site moves the entire story to the opposite side of the planet. Number 5. The Pilauco Bajo footprints, Chile. In the Lake District of southern Chile, about 900 kilometers south of Santiago, sits the Pleistocene archaeological site of Pilauco Bajo. In 2010, a team from Universidad Austral de Chile, led by the paleontologist Mario Pino, was excavating a layer of fluvial silt at the edge of an ancient pond. The silt sealed an older layer that had been buried by peat. When the peat was lifted, a single human footprint emerged. The print was 25 centimeters long. Impression depth analysis put the walker at roughly 70 kilograms, a robust adult male of the late Pleistocene population. The radiocarbon assays on organic plant fragments above and below the print layer returned a calibrated age of approximately 15,600 years before present. That number is the headline. 15,600 years places this human 2,500 years before the conventional Clovis-first arrival in the Americas. The Clovis-first model, established by Vance Haynes Jr. in the 1960s, holds that humans entered North America via the Bering ice-free corridor around 13,000 years ago. Pilauco Bajo sits at the southern tip of South America, requiring those same humans to have walked the full length of 2 continents in something close to 0 years, unless they were already there. The paper appeared in 2019 in the journal PLOS ONE, authored by Karen Moreno, Mario Pino, and colleagues. It cited the broader pre-Clovis evidence base to support the date. Tom Dillahay's Monteverde. To site, about 90 kilometers west of Pilauco Bajo, had already pushed human presence in southern Chile back to 14,500 years. Monteverde, too, had been contested for decades before being accepted as legitimate pre-Clovis in the late 1990s. Other pre-Clovis sites filled in around it. Page Ladson in Florida came in at 14,500 years. Cooper's Ferry in Idaho came in at 16,000 years. The Pilauco Bajo site also produced Pleistocene megafauna remains, gomphotheres, horses, and a deer-like ungulate called antifur. Cut-marked bones in the same layer established that the walker was part of a population butchering large animals. The footprint is not an isolated trace. It sits within a working landscape. Critics led by Stuart Fiedel have questioned the stratigraphic association at Pilauco, though no formal peer-reviewed rebuttal has appeared. Mainstream interpretation: humans were present in southern Patagonia by 15,600 years ago, requiring an earlier coastal migration route rather than the Bering Land Bridge Ice Corridor model. The archaeological alternative is John Erlandson's so-called Kelp Highway model, humans following marine resources down the Pacific coast rather than tramping inland. The fringe reading invokes the still-disputed Monteverde 1 layer, which would push human presence in southern Chile back to 33,000 years if accepted. Environmental DNA and pollen analysis reconstruct the Pleistocene landscape, open step with cold temperate forest patches. The next site contains 257 prints, including a 2-year-old's. Number 6. The Rozel footprints, France. On the Atlantic coast of the Cotentin Peninsula in Normandy, just south of Cherbourg, the cliffs are eroding. Each winter storm pulls more soft mudstone into the sea. In the late 2000s, that erosion exposed a layer of preserved Neanderthal footprints. By 2012, systematic study had begun under Jérémy Duveau of the Muséum National d'Histoire Naturelle in Paris. The numbers came in 2019. Duveau and colleagues published in the Proceedings of the National Academy of Sciences 257 Neanderthal footprints, the largest single Neanderthal trackway assemblage in the world. The age is approximately 80,000 years ago, placed in the early Last Glacial period during a marine isotope stage 5A or 4 cold phase. The track makers ranged from very young children, including a child estimated at just 2 years old, to adults of varying heights. Statistical analysis suggests a group size of about 10 to 13 individuals. The group was dominated by children and adolescents, with relatively few adults. That demographic profile overturns the older caricature of Neanderthals. For most of the 20th century, popular media depicted Neanderthals as small bands of solitary adult hunters, brutish and isolated. Rozel paints a different picture. Whole families lived together. Toddlers walked alongside teenagers and grandparents. The trackways capture multi-generational community life. The prints are preserved in a dune-edge mud layer that hardened rapidly and was then buried by wind-blown sand. The preservation is exceptional, fine enough to show individual toe pads. Mean print length is 19 centimeters, with the smallest at just under 10 centimeters and the largest at 28. The print morphology shows the broad, flat shape characteristic of Neanderthal feet, with a wider forefoot than anatomically modern humans. Handprints and tool impressions accompany some of the trackways, suggesting the makers were carrying objects or performing actions during the passage. The associated archaeology includes Mousterian stone tools, hearths, and animal bones from hunted aurochs, red deer, and horses. Stable isotope analysis of nearby bone fragments suggests the Neanderthals consumed both marine resources and terrestrial game, a less specialized diet than previously assumed. They were eating fish, shellfish, and large game from the surrounding marsh. The team includes Marie-Hélène Moncel of the Centre National de la Recherche Scientifique and Anne-Marie Tillier, pioneers in Neanderthal biology. Time is short. The Rozel cliffs continue to erode. Print impressions are typically lost within months of exposure unless rescue excavated immediately. The Musée d'Archéologie Nationale at Saint-Germain-en-Laye holds the casts and the three-dimensional scans. The originals are mostly already gone. Mainstream interpretation: a multi-generational Neanderthal community lived seasonally at the coast, gathering and processing marine and terrestrial resources together. Archaeological alternative: the trackways represent a single passage event by a traveling group rather than seasonal occupation. The fringe reading proposes the high proportion of children suggests a ritual nursery or initiation site, unsupported by the data, but circulated in popular media. The next site holds 400 prints and a smoking volcano. Number 7. The Engare Sero footprints, Tanzania. On the southern shore of Lake Natron in northern Tanzania, in the East African Rift Valley, a flat plain of pale volcanic mudstone covers several square kilometers. Above it, the cone of Oldoño Lengai exhales smoke. The volcano is unusual. It produces uniquely cool nitrocarbonatite lava at about 510 degrees Celsius, rather than the typical 1,000 or more of basaltic eruptions, and its ash is silver gray. In 2008, Maasai community members noticed footprints in the mudstone. They reported the find to scientists. Formal study began under Cynthia Lutkus-Pierce of Appalachian State University. The full publication came in 2020 in the journal Scientific Reports, led by Kevin Hattala of Chatham University. The number is staggering: 408 individual footprints. They come from at least 17 people walking together. This is the largest assemblage of ancient human footprints anywhere on Earth, more than 4 times the count at Rozel. Dating relied on argon-argon analysis of the volcanic ash matrix and feldspar crystals from Oldoño Lengai. The age range is between 5,760 and 19,100 years ago, most likely toward the older end, placing the walkers in the late Pleistocene. The track makers were anatomically modern Homo sapiens. The foot proportions and the age leave little ambiguity. The group composition is the next surprise. Statistical analysis of foot size and gait identifies at least 14 adult females, 2 adult males, and 1 juvenile. This female-dominated demographic is unusual. Hattala's team interprets it as a foraging party, a group of women collecting plant and animal resources together, with 2 adult male escorts and a child along for the journey. Walking speeds, calculated from stride length, range from 0.8 to 1.7 meters per second. Most are walking briskly. Some pause. Several individuals appear to have walked in a single file column, with footprints overlapping precisely as if following a leader's path. The track surface is a single ash deposit that hardened within hours of exposure to morning dew, locking in the impressions before they could be erased. Animal tracks coexist with the human prints. Zebra, buffalo, and several unidentified ungulates suggest the human group was crossing an animal trail. The site preservation is challenged by both natural erosion and informal tourism. The Tanzanian National Museum installed protective barriers in 2018. Mainstream interpretation: a foraging party of late Pleistocene Homo sapiens crossed the volcanic plain together, likely seeking water at Lake Natron's freshwater margins. The female-dominated demographic supports models of cooperative female foraging in early modern human societies, challenging male hunter caricatures. Archaeological alternative: the all-female group might represent a ritualized seasonal migration, perhaps tied to the volcano itself as a sacred site. Fringe reading: the group represents survivors of an eruption rather than a foraging party, though the calm walking speeds argue against panic flight. The site is now nominated for UNESCO World Heritage status. The next set of prints is nearly 1 million years old. Number 8. The Happisburgh Footprints, England. On the North Norfolk coast of England sits the village of Happisburgh. The beach there is a heavy strip of gray clay backed by eroded brown sandy cliffs. In May 2013, a particularly stormy winter pulled away the protective sediment cover and exposed something underneath. Martin Bates and Sarah Duffy of the British Museum's Ancient Human Occupation of Britain project, known as AHOB, were on the beach. Chris Stringer led the broader program. What Bates and Duffy found were hominin footprints in fine estuarine silt. They were photographed and three-dimensionally scanned within hours. They had to be. The tides were already pulling at the layer. Within 2 weeks, every print had been erased. The paper appeared in 2014 in PLOS 1, authored by Nick Ashton, Simon Lewis, and colleagues. Attribution went to Homo antecessor, the European archaic human, known from the Atapuerca site in northern Spain. The age estimate, based on the underlying Cromer forest bed formation stratigraphy and paleomagnetic data, ranged from approximately 850,000 to 950,000 years ago. That is older than anything else outside Africa. The next oldest hominin footprints sit at Atapuerca itself, at around 800,000 years. Happisburgh pushed the timeline another 150,000 years earlier and put hominins in cold northern Britain of all places. The Happisburgh climate at the time was cold temperate, similar to modern southern Scandinavia. There was pine forest, freshwater wetlands, and salt marshes. The Proto-Thames River still flowed northward to the sea here before the Anglian glaciation diverted it south. The hominins likely arrived via the Doggerland land bridge from continental Europe, which connected Britain to the Netherlands and northern France until roughly 8,000 years ago. Around 50 partial and complete footprints were documented before destruction. Sizes ranged from roughly 14 to 26 centimeters, suggesting 2 to 5 individuals, a mix of adults and juveniles. The track makers walked roughly southward along the river mouth, with strides indicating a deliberate pace rather than running. Cut-marked animal bones found at the same horizon include extinct rhinoceros, hippopotamus, and Pleistocene horse, direct evidence of butchery. Skeletal remains of Homo antecessor have been recovered only at Atapuerca's Grandolina TD6 layer in Spain. The Happisburgh Association is based on age and stone tool similarity, not on bones. Simon Parfitt's 2014 paper described the associated lower Paleolithic stone tools, simple flakes, and cores. Mainstream interpretation: small bands of Homo antecessor reached as far north as the Cromer forest bed coast during a temporary warm interval, hunting and gathering at the river mouth. Archaeological alternative: the track makers were a Mediterranean-adapted population pushed north by climate shifts. Fringe reading: pseudo-archaeological accounts attribute the prints to giants based on the larger size range, unsupported and inconsistent with the actual measurements. The footprints have not been preserved physically. The only surviving record is the photogrammetric three-dimensional model held by the British Museum. The next site survives only because it was sealed off 21,000 years ago. Number 9. The Chauvet Cave Footprints, France. In the Pont d'Arc area of the Ardèche Gorge in southern France, a limestone cliff hides one of the most important sites of Upper Paleolithic art on Earth. The cave was sealed by a rockfall around 21,000 years ago. It was rediscovered in 1994 by 3 speleologists, Jean-Marie Chauvet, Eliette Brunel, and Christian Hilaire, who broke through the rockfall and found the painted chambers untouched. The paintings inside have been radiocarbon dated to between 36,000 and 30,000 years ago. They include the earliest known images of lions, mammoths, woolly rhinoceroses, cave bears, and panthers. The technical sophistication of the art, perspective, shading, animation is so advanced that for years scholars refused to accept the dates. In 1999, the speleologist Michel-Alain Garcia found something even rarer in the cave. 600 meters from the original entrance, deep in a chamber called the Galerie des Mégaceros, the cave floor preserved a trail of human footprints. Garcia and his team documented 70 separate prints, all attributed to a single child walking barefoot through soft cave sediment. The child was aged approximately 8 to 10 years old. The prints are 18 to 21 centimeters long, with a clear arched foot and slight pronation, anatomically modern Homo sapiens. The estimated child height is about 1.3 meters. Radiocarbon dating of torch charcoal smears beside the prints returned an age of approximately 26,000 years. So far, this is a remarkable find, but not a controversial one. Then comes the next detail. Alongside the human prints, embedded in the same layer, are the pad prints of a large canid. Stride and pace alignment indicate that the canid and the child were walking together at the same time, not separately at different times. The canid was either a wolf or a transitional proto-dog. The conventional date for dog domestication is around 14,000 years ago. The Chauvet evidence, if interpreted as a proto-dog, would push that back by 12,000 years. Genetic studies on Pleistocene canid remains have, since the late 2000s, opened the door to early domestication. The Goyet specimen from Belgium, dated to about 30,000 years, shows skeletal evidence consistent with the proto-dog lineage. That gives the Chauvet interpretation a sister site. Critics, led by Mietje Germonpré, have argued the Chauvet canid was simply a wolf following or stalking the child. The trail terminates at a wall. The child appears to have turned around and walked back, but the return prints were obscured by later cave traffic. The footprint floor is now sealed off from public access. A complete three-dimensional photogrammetric replica of Chauvet Cave, called Chauvet 2, was opened to the public in 2015. Mainstream interpretation: a Gravettian period child walked deep into the cave, possibly during a ritual or exploration, accompanied by a wolf or protodog companion. Archaeological alternative: the canid prints predate the human prints by some weeks or months. Fringe reading: the Chauvet Trail is the world's oldest evidence of human-dog partnership. The UNESCO World Heritage inscription for Chauvet in 2014 specifically cites the footprint trail as a key component. The final site is the one that broke the entire field. Number 10. The White Sands Footprints, New Mexico. In the Tularosa Basin of southern New Mexico, the gypsum dunes of White Sands National Park cover an ancient lake bed. The lake was called Lake Otero. It dried out millennia ago, leaving a flat playa of fine gypsum sand. In 2009, a retired National Park Service geologist named David Bustos noticed unusual depressions in the playa surface. He thought they looked like footprints. He photographed them and waited for the experts. It took 12 years to publish the paper. In 2021, a team led by Matthew Bennett of Bournemouth University and Sally Reynolds released a paper in the journal Science. They dated the footprints using radiocarbon analysis of Ruppia serosa seeds, a small aquatic plant known as ditchgrass, embedded in the print layers above and below. The dates were between 21,000 and 23,000 years ago. That is the bomb. 21,000 to 23,000 years is squarely within the last glacial maximum, the period when the Laurentide and Cordilleran ice sheets were thought to make North American interior travel impossible. The conventional Clovis-first arrival date is 13,000 years ago. White Sands predates that by 8,000 to 10,000 years. It is the longest pre-Clovis margin yet documented anywhere in the Americas. Critics moved fast. Lauren Davis raised concerns about radiocarbon dates from aquatic plants potentially absorbing old carbon, the so-called hard water effect. The aquatic plants could, in theory, have taken up carbon from old groundwater, making them appear older than they really were. The critique was serious. In 2023, Jeff Pagati and Kathleen Springer of the United States Geological Survey published a follow-up paper. They validated the original ages using two independent methods: radiocarbon on terrestrial pollen, which does not have the hard water issue, and optically stimulated luminescence on quartz grains in the sediment. Both methods returned dates consistent with the original 21 to 23,000 year estimate. The hard water loophole closed. The number of footprints kept rising. Over 60 prints in the initial publication. Thousands more in subsequent surveys. The track makers were predominantly adolescents and children, judging by print size. Most prints fall under 20 centimeters. Adults appear largely absent. Animal tracks at White Sands include extinct megafauna, Columbian mammoth, giant ground sloth, dire wolf, and American camel. Some trackways show humans and megafauna walking in close proximity within minutes of each other. One famous trackway shows a person carrying a child, periodically setting them down and picking them up, traversing 1.5 kilometers of the playa. Mainstream interpretation: humans were already widespread in interior North America by 22,000 years ago, requiring either a much earlier Bering crossing or a coastal route during a less glaciated interval. The archaeological alternative is the so-called two-wave model, an earlier failed migration that left genetic ghost ancestry, followed by the later Clovis-era wave that founded most modern Native American populations. The fringe reading invokes the Solutrean hypothesis, but White Sands geography and DNA evidence rule it out. That is the 10. Now, the question becomes, how does any soft footprint last a million years? The taphonomy of footprints, the science of how a soft impression becomes a permanent feature of the rock, is the silent character behind every site on this list. Almost every footprint ever made by an animal vanishes within hours or days. The proportion that survives long enough to fossilize is estimated at less than 1,000%. What separates the survivors from the lost? Chemistry, mostly. Volcanic ash is the most reliable medium. The Roccamonfina lucidic tuff and the Engare Sero natrocarbonatite are both ideal preservation materials. They have low moisture, high silicate content, and they harden rapidly when wet or when struck by morning dew. The cooling natrocarbonatite ash from Oldoinho Lengai is particularly unusual. Its silver-gray deposits behave more like wet cement than typical volcanic dust. Other media work differently. Fluvial silts and dune mud at Rozel and Happisburgh preserve prints when the surface dries quickly under sun and wind, then gets buried beneath wind-blown sand before bioturbation by burrowing animals can erase them. Gypsum playa chemistry at White Sands cements the impressions through the action of calcium sulfate dissolved in seasonal water. Cave humidity stability at Theopetra and Chauvet protects clay impressions from desiccation cracking. Sediment grain analysis is now a forensic tool. Panagiotis Karkanos at the Wiener Laboratory in Athens pioneered the application of microstratigraphy to footprint sites, examining individual grain orientations and packing densities to reconstruct exactly how the impression was made and how quickly it hardened. The window between impression and fossilization is narrow. At Engare Sero, prints hardened within hours. At Le Rozel, the dune mud locked in shape within days. At Happisburgh, the Proto-Thames silts froze the prints in place during a winter cold snap. Get the timing wrong by an hour and the layer slumps. The prints distort or vanish. Modern preservation techniques have transformed the field. Photogrammetric three-dimensional scanning is now the standard. Synchrotron tomography, available at facilities in Grenoble and Stanford, reveals subsurface print structures invisible to the eye. Isotopic dating crosschecks now combine argon-argon, radiocarbon, optically stimulated luminescence, and thermoluminescence to triangulate ages. At Pilauco Bajo, all four methods converged. At Trachilos, magnetostratigraphy provided the crosscheck that confirmed the original foraminifera dates. The radiocarbon calibration debate at White Sands sits within this wider methodological evolution. So does the Acahualinca dating chaos. Each method has its strengths and its biases. Radiocarbon stops working at 50,000 years. Argon-argon needs the right volcanic minerals. Thermoluminescence requires unbleached quartz. Combining methods is the only path to confidence. Why most footprints never survive. Bioturbation by worms and insects, weathering, trampling by later animals, exposure to wind and rain, and chemical leaching. The miracle is that any survive at all. The shift from in situ display to digital replication for public access. Chauvet 2, the British Museum models, the Tanzanian Ministry of Tourism digital tours, is rewriting how the public sees these traces. The originals are increasingly off limits. The replicas are increasingly indistinguishable. The footprints on this list challenge two pillars of paleoanthropology. The first pillar is the out of Africa model, the framework that puts the origin of bipedalism, of stone tools, and of anatomically modern humans on the African continent, with sequential dispersals to Eurasia. The standard model is more nuanced than the slogan. Out of Africa, one refers to the dispersal of Homo erectus from East Africa around 1.8 million years ago. Out of Africa, 2 refers to the dispersal of anatomically modern Homo sapiens around 70,000 years ago. Between those two events, the model holds Africa was the engine room of hominin evolution. The Trachilos prints, if they are what their describers say they are, demolish the timing of the first pillar. Bipedal hominins in Europe at 6.05 million years ago means either bipedalism evolved in Europe and migrated south, or it evolved in parallel on two continents. The Happisburgh prints push the timeline of the first dispersal northward to 950,000 years ago in cold Britain. The Theopetra prints, combined with the Apidema 1 skulls' 210,000-year date, suggest anatomically modern humans were in Greece long before the standard out-of-Africa 2 date. Madeleine Baume's so-called Levantine bottleneck alternative model proposes that the entire genus Homo emerged not in East Africa, but in the eastern Mediterranean, Anatolia, the Levant, southeastern Europe. By her reading, the lineage only later spread south. Her supporting evidence is the Grecopithecus jaw and the contested Trachilos prints. The Mediterranean cradle hypothesis has critics, including most North American paleoanthropologists, but it is taken seriously in European literature. The role of Doggerland, the now submerged landmass that once connected Britain to the Netherlands, and Sundaland in Southeast Asia is being reconsidered. Sea level changes during glacial periods exposed vast walking corridors that no longer exist. Hominin migration routes that look impossible on modern maps were straightforward 30,000 years ago. The multiple dispersal model is now favored over the single dispersal model. Genetic evidence from Denisovan and Neanderthal interbreeding, the genomic ghost ancestry visible in modern African populations, the Mislia cave mandible from Israel dated to 177,000 years, the Jebel Irhoud Moroccan sapiens dated to 315,000 years. All of this points to humans leaving Africa in waves, some earlier than 70,000 years. Footprint evidence is more conservative than genetic evidence about timelines. Genes can show admixture events that happened across thousands of generations. A footprint shows one walker, one moment. But when footprints triangulate against fossils and genes, the field tends to listen. The current consensus is shifting. Africa remains the center of gravity for hominin evolution, but the timing of the dispersals and the number of those dispersals is being revised in real time. Why does the model resist overhaul? Institutional inertia and dating uncertainty. The next 20 years of paleoanthropology will likely be dominated by trace fossils and redated sites, not by new skeletal finds. The second pillar being demolished is the Clovis-first model for the peopling of the Americas. This is a younger paradigm than the out-of-Africa framework. It dates to the 1960s, but it has been dominant for nearly 70 years. The Clovis-first model holds that humans entered the New World via the Bering Land Bridge around 13,000 years ago, after the Laurentide and Cordilleran ice sheets retreated enough to open an ice-free corridor through what is now Canada. Vance Haynes Jr. established the chronology in the 1960s, based on the radiocarbon dates of Clovis culture stone tools at sites across North America. For decades, no earlier site could survive peer review. Sites that claimed earlier dates were dismissed. Calico Hills in California, the Tool Springs site in Nevada, the Old Crow Basin in Yukon, each was eventually rejected as misdated or misinterpreted. The model held. Then, Tom Dillahay's Monte Verde II site in southern Chile, published in 1997, finally cracked the consensus. The site was dated to 14,500 years ago. Dillahay's evidence, wooden structures, mastodon bones, preserved plant remains, was robust enough that a panel of skeptics visited the site and conceded. Monte Verde II became the first widely accepted pre-Clovis site. Other sites followed. Page Ladson in Florida was confirmed at 14,500 years using underwater archaeology techniques. Cooper's Ferry in Idaho, excavated by Lauren Davis, pushed back to 16,000 years and was associated with Western stem tools rather than Clovis points. Pilauco Bajo in Chile came in at 15,600 years. The 2021 White Sands paper functioned as the demolition charge, 21 to 23,000 years, the Last Glacial Maximum. The ice-free corridor was not even available at that time. Bluefish Caves in the Yukon, reanalyzed by Lauriane Bourgeon, returned dates of 24,000 years. Chiquihuite Cave in Mexico, published by Cyprian Ardelian in 2020, returned dates of 32,000 years. The Hartley Mammoth Butchery Site, described by Stephen Holan and colleagues, pushed back to 37,000 years. The Karuti Mastodon site at 130,000 years remains highly contested, but has not been refuted. The Beringian standstill hypothesis emerged from genetic data. It proposes that a founding population was isolated for around 10,000 years on the now submerged Bering Land Bridge before dispersing south. The Kelp Highway coastal route alternative, proposed by John Erlandson, fits the Southern Pacific dates better than the ice corridor model. The two-wave migration model accommodates an earlier, failed migration that left ghost ancestry, followed by a Clovis-era wave that founded most modern Native American populations. The Solitrian hypothesis, humans crossing the Atlantic from southwestern Europe, has been rejected by DNA evidence. Indigenous oral traditions matching Ice Age timelines are now being treated as primary data rather than folklore. The Mescalero-Apache collaboration at White Sands integrates indigenous-led research with the archaeology. The Clovis-first paradigm is, for all practical purposes, dead. Across the 10 sites, a pattern emerges that none of the original papers fully addresses. Children's footprints dominate. Theopetra holds 4 prints of children aged 2 to 4 years old. Rozel holds 89 confirmed child prints out of 257. White Sands is dominated by adolescent and child prints, with adults largely absent. Chauvet's Deep Cave Trail is a solo journey by an 8 to 10-year-old. Engare Sero contains a juvenile in the female-dominated foraging group. Trachilos' prints range down to 9 centimeters in length, small enough to suggest hominin juveniles among the adults. Why are children so overrepresented? 3 hypotheses circulate. The lighter touch hypothesis suggests that children's lighter bodies leave shallower prints, which are easier to preserve because they do not disturb the deeper sediment. The playful exploration hypothesis suggests children wander into ash, mud, and caves more often than focused, task-oriented adults. The perfect ash interpretation suggests that ash hardening windows happen to coincide with children's higher energy levels and movement frequency. What does this tell us about prehistoric life? Cross-cultural patterns in modern hunter-gatherer studies, research on the Hadza of Tanzania, the Ashe of Paraguay, and the Aka of Central Africa show that children in foraging societies spend most of their day in mixed-age groups, often without close adult supervision. They play near settlements, follow older children into the bush, and contribute economically from age 5 or 6 onward. The 2019 PNAS paper by Jeremy Duveau on the Rozel made a specific argument. The child footprints suggest Neanderthal children participated in food sourcing alongside adults, learning the tasks of adult life through embedded apprenticeship rather than formal instruction. Footprint evidence of children carrying or being carried, the white sands trackway of a person setting a child down and picking them up, gives us a direct window on Pleistocene parenting. Pleistocene alloparenting is inferred from the demographic profiles at Engare Sero and Le Rozel. Multiple adult females, including non-mothers, may have shared childcare and resource gathering. The cognitive implications of children in dangerous landscapes deserve serious consideration. The Chauvet child walked 600 meters into a dark cave, accompanied only by a torch and possibly a canid. The Le Rozel 2-year-old walked on a marshy coastal flat near the Atlantic shore. The Theopetra children played in a cave system in central Greece during a period when bears, hyenas, and large carnivores hunted regularly in the surrounding hills. The challenge of attributing intent, play, ritual, necessity, accident is the boundary of what footprints can tell us. They show motion, demographic, group composition. They do not show motive. But the emotional reach of children's footprints in modern public engagement is one reason these sites command attention. A child's footprint in volcanic ash is harder to dismiss than a fragmented adult skeleton in a museum case. It is intimate. The child was here. The child was small. The child walked. The footprints on this list are a fraction of those that ever survived. The survivors are themselves a fraction of those originally made. Estimated proportions vary, but most ethnologists agree. Less than 1/1000% of impressed footprints ever fossilize. The historical record being argued over is built on a vanishingly small sample. Sites currently being destroyed by erosion include Rozel, Happisburgh, and Acahualinca. The cliffs at Rozel lose impressions every winter. The Happisburgh beach is now functionally empty. The prints documented in 2013 survive only as photogrammetric models. Acahualinca is preserved under a museum roof, but the surrounding stratigraphy has been disturbed by urban construction. Sites awaiting full publication include additional Trachilos layers, adjacent slabs at Engare Sero, and several uncatalogued chambers at Theopetra. Permafrost thaw across the Russian Arctic and Beringia may yet expose Siberian footprint sites, and probably will, given the rate of warming. The Indonesian and Philippine archipelago footprint potential remains largely unexamined. Wallacen root hominin tracks, predicted by recent skeletal finds in the region, are still undocumented. Underwater archaeology is the second frontier. Doggerland seafloor surveys, using LiDAR and side-scan sonar, are mapping the submerged landscape between Britain and the Netherlands. Atlet Yam adjacent sites in the eastern Mediterranean and the broader submerged shelf of the Mediterranean rim may yet hold footprint horizons from glacial periods when sea levels were 120 meters lower. High-resolution drone photogrammetry is transforming field discovery rates. Indigenous-led archaeology is shifting the geography of investigation. The Mescalero Apache at White Sands, the Wampanoag in the northeastern United States, and the Zapatawayak in central Canada are now leading projects that previously would have been led by outside researchers. Open data archives democratize three-dimensional scans. Citizen scientists identify coastal exposures from satellite imagery. The next paradigm-shifting discovery is most likely to come from redating, not from new digs. The current rate of timeline revision sits at roughly one major shift per decade. The 2030s may be the footprint decade in paleoanthropology. So is our timeline wrong? It always has been. The framework keeps moving as new evidence arrives. The Trachilos prints might be reinterpreted as tetrapod tracks tomorrow. The Theopetra children might be sapiens, Neanderthal, or a population we have not named. The Chauvet canid might be a wolf or the world's oldest dog. The honest answer is that the timeline keeps being rewritten, and the footprints under our feet, preserved or eroded, dated or undated, are still telling us we have not heard the full story yet.